7:30, our faculties are presenting lecture on latest technologies. As part of this event, today, Dr. K. Ramana sir from HNS department, he is going to share his knowledge on organic chemistry. Sir, I welcome Dr. K. Venkatramana sir. So please, sir, start the session.
Okay, sir. Good evening to respected professors and beloved students. Today I would like to give presentation organic chemistry, especially a brief introduction about NMR spectroscopy. It is applicable to various fields to identify the structure analysis of especially organic compounds. So this is Dr. K. Venkatramana, Assistant Professor, Department of Chemistry, H&X. So I have completed PhD from Sri Venkateswara University, Tirupati, under the guidance of Professor C. Nagaraj Sir Garu. And title is, my PhD thesis title is Synthesis, Spectral Characterization and Bioactivity Evolution of Organophosphorus Compound. After completing PhD, I have done postdoctoral fellow, Institute of Chemistry, Chinese Academy of Sciences. So this is my
Please,
education. So next, sir, tell me, sir.
slides, sir. Please go to slides, sir.
Okay.
Share your screen, sir.
Okay, sir. So
Sir, right side there is a bowl shape, sir, button. You click on that, sir. Right side below. Yeah.
Yes, sir.
Yes.
Now it's okay, sir.
Okay, sir. So,
Any problem, sir?
Make it full screen, sir.
Yes, sir.
Press F5, sir. Press F5 key, sir, function key.
So spectroscopy, it is study of the interaction between electromagnetic radiation and matter. So matter, it may exist as like atoms, molecules, and ions. So basic principle, the interactions between electromagnetic radiation and matter. So electromagnetic radiation is one of the energy. So it is exist like electrical and magnetic waves. But the electric field and magnetic field both are oscillating perpendicular to each other or perpendicular nature of the wave. So nuclear magnetic resonance spectroscopy or simply NMR. So this technique, it is a powerful technique to analyze the characterization of organic molecules like chemical structure and functional groups to determine by the proton and carbon, especially proton NMR spectroscopy and also C13 NMR spectroscopy. So this is NMR spectroscopy.
sir, your slide is not moving, sir. Your slides are not moving, sir. Yeah. So it's a third slide, sir.
Yes, sir.
Yeah, go ahead.
So NMR spectroscopy, so based on 100 megahertz, 300 megahertz, and 500 megahertz, and 700 megahertz. To identify the structural analysis of organic compounds. So based on mega edges increases, the simplification of spectrum is very good. That means resonance is fast. So here based on NMR principle, first nuclei is active. So that one gives the NMR signals. So all nuclei are electronically charged and have some spin, like positive spin or negative spin. When you apply the applied field or applied magnetic field, the nuclei undergoes from ground state level to edge state, and also edge state to ground state when observing the resonance condition. That time gives the signal. So that signal indicates structural analysis of molecules. So that is basic principle. So for example, so nuclei active spin means that is I equal of R1, R2 like this one. So 0 means that is inactive. So inactive species does not undergo spin relaxation. So spin relaxation means ground state to edge state and edge state to ground state when absorption takes place and emission takes place. So absorption takes place means the nuclei from ground state to edge state when observing the electromagnetic radiation. So in NMR spectroscopy, electromagnetic radiation is radio waves. Emission means when fall down from the edge state to ground state. So most of the spectroscopies based on only absorption spectroscopies. So this is main basic principle. So NMR spectroscopy working condition. So if sample place in the sample.
Sorry for the disturbance, sir.
Sir, tell me, sir.
Sir, can you try once again, sir? Below bottom bowl shape. You press on that, sir. Actually, the words are not clear, sir, here. No change. You selected entire screen, sir.
Yes, sir.
Okay. Okay. Okay, sir. Go ahead, sir. Please proceed, sir.
Okay, sir. Working of NMR spectroscopy, place the sample in magnetic field. That means applied magnetic field. So when apply the magnetic field, the sample have some active nuclei from ground state to edge state when observe the electromagnetic radiation, that is radio frequency, to produce the NMR signals. So that NMR signals detected by radio receivers or radio signals. That signals give the molecule individual functional group and also chemical structure. So based on these signals, we identify the structure of molecules or identification of the molecules. So based on this thing, provide details of structure, chemical environment, and also stability of a molecules. So NMR spectroscopy applications. So that is, first one is structural determination, detection of functional groups, distinguish the intramolecular hydrogen bonding and inter-hydrogen bonding, and study of some cis and trans compounds. So these calculations based on chemical shift values. So based on chemical shift values, so chemical shift, it expresses the delta, and also it is represented parts per million of frequency. So delta equal sample reference frequency minus reference standard, that is tetramethylsilane. So that is reference standard for NMR spectroscopy. Observing the radiation gives the signals with zero condition. That value is delta value is 0 divided by instrument operating frequency into 10 power 6. So this is common value for all NMR values. So first one, for example, structural determination. Suppose our simple compound is methane molecule, that is CH4. So carbon containing 4 hydrogens, that is same environment.
Sir, can you move the slide to 100%, sir? Move the slide to 100%, sir. No, yeah, slide. Here the percentage is less here. Yeah.
Replace with symbol, sir.
Yes, yes. Okay, 100%. Only 100%, sir. Sir, set at 100%, sir. Okay, fine.
100%, sir.
Okay, good.
Thank you, sir. CH4. So simple compound. So carbon containing 4 hydrogen atoms. So this is single environment, or simply same environment attached to the carbon. So it gives the single peak. Or next one is ethane compound. So ethane compound CH3, CH2, CH3. So C3H6 molecular formula. The structure is CH3, CH2, CH3. We can apply the NMR spectroscopy. Here two environment is, one is CH3 group, another one is CH2 group. For structural analysis determined by NMR spectroscopy. So one carbon containing 2 hydrogen atom, next carbon containing 3 hydrogen atom. So 3 hydrogen atoms are same environment. In between the second carbon, that is 2 hydrogen atoms. So it is varying the different NMR values. Based on chemical shifts values, we can determine the structure of compound. So this is methane compound, this is ethane compound, this one is propane, this one butane, some etc. Based on the number of hydrogen attached to the carbon. And also like primary carbons like CH3 group, that is methyl group, CH2 group, that is methylene group, CS, that is ethane group, based on the carbon attached to the carbon. So next one is detection of functional group. So other than carbon and hydrogen, OH group like alcoholic group and aldehyde group CHO, or keto group COO group, and acid COOH group. Other than carbon and hydrogen, we can determine these groups also. Like OH group containing any molecule, the delta value varies from 4 to 6 ppm. And aldehyde group containing any molecule, the value is delta value is 9 to 10. So just sample, put in a NMR tube. Within minutes, we can get the signals. So then identify the unknown compounds also. Suppose we are prepared in laboratory, we don't know which composition present, like carbon, hydrogen, or nitrogen, or sulfur, or oxygen. We don't know structure of the compound. But when you put the NMR instrument, the sample put the NMR instrument, it gives the minutes. Within minutes, we can get the signals. Based on that values, we can calculate so this is CH3 group, this is CH2 group, this is CHO, this is OH. So finally, we can, most of the time, 80% of the compound is completed within NMR spectroscopy. So next remaining spectroscopies are like molecular IR spectroscopy, UV visible spectroscopy. So etc. Based on that spectroscopy, finally we can 100% structural analysis of the
Sir,
compound.
please move your slide, sir. Slide is not synchronized, sir.
Sir, better you go for presentation, sir. Slideshow.
Can anyone can sir guide him, sir, please. Sir, slideshow, sir.
Yes, sir.
Please go to slideshow, sir. Top of your menu, slideshow.
Sir, press
Or F5.
F5. Press F5, sir.
Yes, sir.
You are using laptop, sir?
Sir.
Sir, it's a better to disconnect and again connect it, sir. Stop your presentation again. Start your presentation, sir.
Madam, చెప్పండి మేడం. ఉంది మేడం. ఓకే మేడం. సైడ్ స్టోన్ ఓకే మేడం. ఫ్రమ్ కరెంట్ స్లైడ్. ఇప్పుడు చూడండి మేడం, అట్లా చేశాను మేడం, ఒకసారి చూడండి.
Sir, Venkatramana, sir.
Sir.
Sir, please once stop your presentation again connect it, sir. You try it.
Okay, sir.
Sir, now click on present now, sir. Sir, is it audible, sir? Venkatramana, sir?
Sir, audible, sir.
Okay, fine.
Now already present now, sir.
Yeah, yes. Okay. Now go for slide, so sir. Not percentage, sir. You go to slide show. Percentage is kept at 100%, sir.
Slide show. పైన అనిమేషన్ పక్కన స్లైడ్ షో వచ్చింది సార్, పైన టాప్ లో.
రమణ కీబోర్డ్ లో F5 ప్రెస్ చేయండి.
ప్రెస్ చేశాను సార్.
Okay.
బిగినింగ్ కొట్టండి.
From beginning, sir.
It's okay, sir.
No change. Sir, go to slide show and from the beginning, sir.
Okay, sir. Sir, now it's okay, sir.
You are at slide 3, sir, now. You are at slide 3. Okay, sir, continue, sir.
F5 వచ్చేసి రావట్లేదు సార్. F5 పైన
Yeah, maybe some problem. Yeah. Please, sir, go ahead, sir.
So based on chemical shifts, we identify some structural molecules. Like methyl group means the chemical shift value 0.9 ppm, methylene means 1.3 ppm, methyl group means 1.4 ppm, or alkene unsaturated compound C containing methyl group means that is 1.7, keto group the methyl hydrogen 2.1, suppose phenyl group present that is 2.3, alkane group containing hydrogen that is 2.4, some ether compound methyl group containing hydrogen that is 3.3 values. So based on chemical values, we can analyze the structure of compounds. Suppose phenyl group containing hydrogen, that value is 6.5 to 8 ppm. So aldehyde group means that is 9.0 to 10 ppm. And also halogen elements like iodine, bromine, chlorine, the values iodine means containing hydrogen that is 2.5 to 4 ppm, bromine means 2.5 to 4 ppm, both are similar. Mostly bromine is higher than the iodine containing hydrogen molecules. Just chlorine 3 to 4, chlorine 4 to 4.5, and some functional group amine group means that is 1.5 to 4 based on various chemical compounds attached to the hydrogens. Next one, alcohol that is 2 to 5, aromatic compound that is phenol compounds or C6H5OH. That hydrogen it varies like 4 to 7 and sometimes 9 also. So finally, acid or acidic compounds gives the high values 10 to 12 ppm, or some carbocations that is highest values. So NMR spectra for simple molecules or small molecules. So we know very well like ethanol compound. So ethanol compound means so commonly called alcohol. So alcohol compound it is CH3CH2OH. The chemical structure of this compound is CH3CH2OH. So here CH3 group is varying CH2 and OH group. So three chemical environment. So CH3 group attached to the CH2 group. When we calculate the methyl group or CH3 group, in surrounded by 2 protons is there. So that's why the 2 protons in based on n+1 rule. So 2 protons surrounded by that reference compound means reference substrate means gives the n+1 value. So that means triplet value. So triplet means the ratio of the peaks 3 peaks. Triplet means 3 peaks. Doublet means 2 peaks. Quartet means 4 peaks. Quintet means 5 peaks. So based on peaks surrounded by 2 hydrogen means that is triplet. 3 means quartet. 1 means doublet. So CH3 is surrounded by CH2 group, 2 protons. It is 1 is to 2 is to 1 ratio. The NMR spectrum signals gives 1 is to 2 is to 1 ratio. Next one is CH2 group. So CH2 group surrounded by one side is OH group, another side is CH2 group. So 3 protons. So that's why it gives the quartet signal. So quartet means the ratio of the signals is 1 is to 3 is to 3 is to 1 ratio. The OH group attached to CH2 group. So this one gives oxygen, most electronegative element attached to the hydrogen. So this gives the mostly broad peak. So this is identification of the ethanol compound, and similarly toluene. So these are solvents regularly used for the laboratory purpose. So most of the some organic compound dissolve in like ethanol, toluene or methanol, DCM, dichloromethane or chloroform, and etc or DMSO. So based on polarity, some compounds easily dissolve in like ethyl acetate and hexane also. So this one is toluene compound. So toluene, it is two environments. So one is alkyl environment, another one is phenyl group or aromatic ring containing methyl group. So CH3 attached to aromatic C6H5, so 5 hydrogens there. So this one gives the multiplate. So aromatic rings, it gives the multiplate peaks, not easily separatable like doublet, triplet, like this one. More than quintet, that is multiplate peak. So in this two environment, 5 protons gives the multiplate peaks. 1 proton gives the, that is desilting field. Desilted proton that gives the values moves to like approximately 2.6 like this one. So commonly methyl groups gives only 0.1 to 0.9 to 1. Approximately 1.2. But in desilted protons, it gives the higher value. Next one, acetone. So acetone compound, this one also solvent. CS3, C double bond O, CS3. Or C2S6O. So here 6 protons are same. CS3 C double bond O or CS3 C double bond O. So that's why it gives the only single peak. So that's one also the desilting field. So that's one also moves to the higher value, higher chemical shift value. So that is 1.7. Thank you, sir.
Okay, thank you, sir.
So this is brief introduction of NMR spectroscopy.
Okay, sir. Thank you, sir. Thank you very much for sharing the knowledge on organic chemistry. Okay, any faculty or any student, if you're having any doubt, you can ask, sir. Okay, sir. Okay, sir. Thank you, sir. So thank you
Thank
very
you for
much, sir.
giving opportunity, sir.
Okay, sir. Okay, sir. Okay.
Thank you for
So,
giving opportunity, sir.
okay, sir. Thank you, sir. So, so now the session is over, sir. Now we start end the session. So thanks all the participants, faculties, students